Hi everyone, today we're going to review geometric and algebraic sequences and series. Get ready to unlock the power of math together. Let's dive right in. So here are your formulas for sequences and series. Now your top row is the arithmetic, and the bottom row is the geometric. So make sure that you understand that the D stands for common difference, and then the R stands for your common ratio. S stands for the sum, and your A sub 1 is your first term, and then A sub n is your nth term, whatever that might be. Okay, so here we're going to write the first 5 terms of this sequence, and here you have A sub n, you have your formula. So our first 5 terms, we're going to find A sub 1. So we're going to take 1 and substitute them in for all the n's that you have. So 3 to the first, and then times negative 3 times 1 plus 2, and that would get us negative 3. So that's A sub 1. A sub 2, same thing, but you're just going to substitute 2 in, and you're going to get negative 36. A sub 3, and then you have negative 189. A sub 4, you're going to get negative 810. And then A sub 5. And then you have negative 3,159. So here are your first 5 terms of your sequence. All right, so here we're again going to write our first 5 terms. So we know our first term. Our first term, our A sub 1, is 7. So that one we got here. Now, when we do this question, because you see this A sub n minus 1, that means you're going to use the previous term, not the number of the term, but the answer. So when you're trying to find A sub 2, whatever you see that A sub 1, you're going to take that 7, and you're going to plug that in, and then you're going to add 4 and then square it, so that'll give you 121. And for A sub 3, same thing. You're going to take that 121, add 4 to it, and then square that answer, 15,625. A sub 4, again, take this answer, 15,625, add 4 to it, and then square. You've got a really big number, 244 million. And then 641. So there's your 4th term. And your last term, A sub 5. Take that, add 4, square it, and you have 570,533. And then you have 1, 2, 3, 4, 5, 6, 7 zeros there at the end. All right, in this question, we're going to evaluate, and you have a sum, so you have that sigma notation. Your first number to substitute is always going to be like below that sigma, and then your final number to be substituted is going to be above that sigma notation. So we're going to take, when you're A sub 1, we want to know is that you take that 1 value, and then you're going to substitute that in for k. And then there's your first term. Your second term is same thing. You're just going to substitute 2. And that's 6. A sub 3, so your third term over 3, that's going to be, let's see, 19 over 3. Your A sub 4, 7 times 4 minus 2 over 4. That's going to be 13 over 2. And when you're trying to do that sum, you're going to take each of those values and you're going to add them together, right? And so what you'll have is 143 over 6, or you have 23.83 repeating. So either one will be great. All right, so here we want to identify if this is convergent or divergent. So if this sequence is convergent, that means you're going to approach a specific value. So you're approaching like one particular value. It is divergent when, let's say, your values are going to approach like positive or negative and infinity, or never approach a single value. So here, this one's actually going to be divergent, because your numbers will keep getting bigger and bigger. So that's something to be aware of, right? You don't know what that end is, so we're going to assume that you keep going and increasing up to infinity. Okay, here we're going to find the 133rd term in this sequence. So whenever you're trying to find a term, you're going to use your explicit formula. Now, how do you know whether this is arithmetic or geometric? Because of this minus 2. That is your difference, your common difference. That is either adding or subtracting. That's what the D represented. So here we're subtracting. So we're going to use our arithmetic formula. So that was this one right here. So we're trying to find the 133rd term. So my first term is 11, and I'm adding 133 minus 1, and then I'm multiplying by that negative 2. I'm not subtracting 2, I'm multiplying by negative 2. And your value is negative 253. Okay, so here we're going to write the explicit formula, and we have an arithmetic sequence. You have a sub 1 and you have a sub 16. So what we're going to do is we're going to look and we're going to make what we know is a general formula. So we have to find some information from there, because this is our general formula right now for an arithmetic sequence. So right now, all we know is our a sub 1, right? Our a sub 1 is 4, and that's all we know. Okay, so we would want to make our general formula here. So we're going to have to figure out what that difference is. So what you can do is, again, you can figure out what the slope is for an arithmetic sequence to find D, or what you can do is you can plug in your values back into this same kind of general formula to be able to figure out what the D represents. So we can just use the 49. So our 49th term, in a sub 1 we know was 4, right? And then we are adding, we know that this is our 16th term, and we're trying to figure out what D is. Okay, again, we're using 49, and that's the fact that it's the 16th term, thus we get those values there. And as you simplify, subtract the 4, you got 45 is equal to 15 times D, so D is going to equal 3. So we're going to take that 3 value and plug it back in here. And again, because you have a general formula, we're going to keep N as it is. So as you simplify, you got 4 plus, we're going to distribute. So you have 3n minus 3, so a sub n is 3n plus 1. Here in this series, we're going to write this in sigma notation. So let's figure out what's happening in our series. I'm adding 4 every single time. Okay, so we know that that is our difference here. So we are trying to figure out sort of that general formula for this series, so we can put that in that sigma notation. So let's use a sub n and figure out what our general formula would be. So I have a sub n. I know a sub 1, that's 6. And again, generalizing, and you have 4, because that's the common difference. As you simplify, you would distribute, so that's 4n minus 4. So a sub n, or my general formula, will be 4n plus 2. So in your sigma notation, my general formula will be 4n plus 2. Okay, all right, so here, this is our first term. So we're always starting off n is 1, okay? But we're now trying to figure out what this term would be, that 50. Okay, so what we can use is we can say, hey, I had a general formula right here, so let me use that to figure out what my n would be. So if I use a sub n and I have my general term, if I put 50 in, you'd be figuring out what is that n? What is that number of term where the answer is 50? So if I subtract, I get 48. So n is 12. So this 50 is our 12th term in that series, and now you've written your series in sigma notation. Okay, here in number 8, we're going to figure out auditorium. We have 25 rows of seats. If there are 18 seats in the first row, so we have 18 in the first row, you have, in the second row, you have 21. In the third row, you have 24, and so on. So that means I am adding 3 seats per row every time. Okay, and I know that this number here of 18, I know that's my a sub 1, right? There are 18 seats in that first row. So let's first figure out, I know my a sub 1, but I want to figure out what is my a sub 25, right? Because I want to figure out how many seats are in that last row. So let's again use our general formula. This is arithmetic because I'm adding 3 every single time. So if I find a sub 25, and I know a sub 1, which is 18, and I'm adding my, let's see, my 25th row, so 25 minus 1, and I'm adding 3 every time, that is D, my a sub 25 is 90 seats, okay? So what I want to do now is I want to use that arithmetic sum formula here. That was this one. Okay, and what I'm going to do is I'm going to say, okay, well, I have a total of 25 rows, right? So what I'm going to do is my n is 25, and then over 2, and then my a sub 1 I know is 18, and then my a sub n I know is 90. So then I can figure out I have 1,350 seats. The first thing you want to see is that this is different than our previous sigma notation for our sum because I don't start at 1, right? K actually starts at 13 and goes to 29. So the number of terms that I have will be different. I have 29 minus 13, but then I'm also going to add 1 to it because I want to make sure I'm including that 13. So I have total of 17 terms. Now what I want to do is look and see what my formula is. This is arithmetic, right? This looks like a little linear formula here. So my arithmetic, that sum, again, that formula is S sub n, and then n over 2, and then a sub 1 plus a sub n. Okay, so you know what your n is going to be, right? Our n is 17. You have to find a sub 1. Now, a sub 1, our first term, is not really a sub 1. It's the 13th term. That is technically the first term here. So I'm going to take 13. I'm going to plug it in for n into my formula here. That's negative 69. So that's negative 69 is my first term. And then I'm going to add my last term. Now, my last term is technically the 29th term because that's the only little part that I'm looking at. So I've got negative 5 and 29 minus 4, which is negative 149. And I'm going to figure out my sum, which is negative 1,853. Okay, here we're going to find the 13th term of your geometric sequence. So what you do want to do is look and see what your formula is. We're trying to find the 13th term. So here's the formula I will need to use. I know my a sub 1, that is 5. And now I'm going to figure out my r, which is 1.75. I'm looking at, again, the 13th term. So a sub 13, and I got 13 minus 1. So my final answer, a sub 13, is 4,125.03. Okay, here we're going to look at 10 to 2, and then to 2/5, and then to 2 over 25. So what I'm doing is I'm multiplying by 1/5. So when you're multiplying, you actually have a geometric. So what I want to do is say if I write my sum, I do need our little formula as well as what we're starting with, which is my first term here, which is n equals 1. I have the dot, 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 so I'm going to infinity here. Okay. Now when I write my formula, okay, what I want to do is, again, use that explicit formula. This is a general formula, right? So a sub n, that was this one, and then r to the n minus 1. Okay, so what I'm doing is I'm saying, okay, my general formula, I got 10 is my first term. My r is, what am I multiplying that by? The ratio. And then n minus 1. So I'm going to take that, and that will be my formula for my sigma notation. Okay, here we've got a summation here. When you look at this formula, it looks like an exponential, so that means that this is going to be geometric. So what I'm doing is I'm saying, oh, my s sub n, my sum, is a sub 1, and then my formula, 1 minus r to the n over 1 minus r. Okay, so what we're doing is we're going, starting at 1, going all the way to 13. So that is a total of 13 terms. Okay, so n is 13. You are starting off with a sub 1. A sub 1, first term there, that's 3. And then you are subtracting 1 minus my r value is the 1/3. And I'm raising it to the n power, so that is 13. And then I'm dividing this by 1 minus my ratio again, which is 1/3. Okay, be careful on how you plug this into your calculator, so make sure you don't make any mistakes there. And your sum is about 4.50. Okay, here number 13, again a sum, but this is an infinite because you see an infinity here. So your formula is a sub 1 over 1 minus r. So what we're doing, our a sub 1 here, negative 2 over 1 minus your r value, which is 1/2. So my sum is going to be negative 4. Thanks for learning with me today, unlocking the power of math one problem at a time. Don't forget to like and subscribe for future notifications on Precalc videos. See you in the next lesson.